2.1 is representing relations and functions. Okay, there are 4 types of ways that they kind of go through how we can represent relations and functions. And one is ordered pairs. Who knows what ordered pairs are? Can someone give me an example of ordered pairs?
4,
4, 3. Okay, so 4, 3 is an ordered pair. Okay, anything in parentheses like that, where I can graph it on a graphing axis and plug in my points. Okay, what would be an example of a table?
Pie.
Pie chart's different.
What do you mean?
How could I represent? I can represent ordered pairs in a table form. How does that work?
Have like one ordered pair together and another ordered pair together.
Sort of.
All
How
X
about
and Y.
yes? How about we list all of our x's on one side and all of our y's on one side, like 2, 3, 7, -9, whatever it is. Okay, that is a table form. So I can do ordered pairs. I can do tables. What's a graph? A graph. Good. What type of functions can I graph? Linear functions. I can graph quadratic functions. I can graph all different types of things. So it'd be like here and here, and I graph this line. Okay. So I can represent it through ordered pairs, tables, through graph. Does anyone know what a mapping diagram is? I actually have one on the board already.
So
What a mapping diagram is. Yes, so it's kind of like this. When I have inputs and output functions, this is a mapping diagram, okay? So it would be like input, output, and it would show me how they relate. 2, 7, 4, 3, 1, 6, 2, and it would show me how they relate. What my input was, what my output was, okay? That's a mapping diagram. So those are just some terms that you might want to get familiar with because they're going to ask you to like put it in a table form, put it in a mapping diagram. So you need to know what those words are. Does that make sense? Okay. Terminology. Okay. Then we are going to get to ordered pairs. So here I listed 4 ordered pairs: -2, 3, -1, 1, 1, 3, 2, -2. Okay. Those are all some ordered pairs that we have. And it says, consider the relation given by these ordered pairs. Identify the domain and range. Who knows what domain is? X. Domain is how far does it travel on my x-axis. Domain is width, okay? How far does it travel on my x-axis? Which makes range to be what? Y, how far it travels up and down, okay? In this case, they're just ordered pairs. This isn't a line. This isn't a quadratic function. So what are all of my domains in this case? List all of my domains. Good, Isabel. -2, -1, 1, and 2. In this case, I have 4 ordered pairs, so I have 4 domains because I have 4 x's. Okay? So domain is x. Range is y. So what is my range? What are my ranges in this case? Okay, 3, 1, 3 again, and -2. So I don't have to necessarily list out 3 2 times. Okay, I can list it. We'll get to that. Yes. So Isabel says let's put them in order. So -2, 1, and 3. Okay. Order is nice when we put them in order. That is lovely. Okay. So then they might say something like this in your homework. Represent those ordered pairs in a graph, okay, and represent them in a mapping diagram. So if I graph these, you guys can graph each of these points on a graph, yes? Okay. I would just make my little x-axes and y-axes, and I graph -2, +3. And then I'm going to label it on my graph so that I know what it is, because we're just going to have a bunch of points on one graph. Okay? You don't have to do a separate graph for each one. And then if you were to put this into a input-output diagram, that is where I would need to list 3 twice. Okay? Because 3 matches twice. Because 3 matches with 2 different things. And so I have to list 3 twice in that case. So when I'm doing my input, output. Okay, I'm going to list all of them in order, like Isabel said, -2, -1, 1, 2, and 3, -2, -1, 1, well, 1 and 2, I only put 3 up here. And then I'm going to list it as, over here, my output, I'm going to list in order as well. So I have -2, 1, 3, and 3, and then I would draw arrows to where they go. So -2 goes to one of my 3's, -1 goes to 1, 1 goes to one of my 3's, and 2 goes to -2. So that's how I'm going to do that. Does that make sense? Okay. So when you're doing homework tonight, you're going to have to do those things. Okay. Now, identifying a function. We need to talk about the definition of a function right here. A function is a relation for which each input has exactly one output. So there's only one output for each input. Okay? So then I come over here to this purple section, and I gave you a mapping diagram here with inputs and with outputs. And I want to know if this is a function. Does each input have exactly one output?
Oh, yeah.
Yes, okay? Because it doesn't matter if they share the same output, it matters about if the input is getting split in two directions. So in this case, this would be a function, okay? So this one is a function. Now, this second one, B, is that a function? Does every input have exactly one output?
No.
No. So in this case, this is not a function, okay? So on your homework, they're going to ask you things similar to that. We have to be able to decide if something is a function or not. So think about this with me. When we do equations, we have linear functions and we have quadratic functions for sure. You're used to those two mostly, right? Quadratic function means, what type of equation would that be? What type of equation would a quadratic function be? Not necessarily multiplication. Quadratic means what? What does quad mean? Not necessarily. Okay, quadratic functions are a little confusing. A quadratic function is what power? What power is with my quadratic function? Do you remember? Yes, a squared, a second power. This here is a quadratic function, okay, a square, okay? So when I'm squaring stuff, sometimes I have two outputs, right, with something, because I could have negatives going on in there and positives, and things can change. So we're going to have to decipher if things are functions, depending on if they are what goes in and what comes out, okay? Okay, so you guys, I believe, have dealt with the vertical line test before, yes? I would assume so in algebra. Okay, what does the vertical line test tell me? Because I haven't finished this picture yet. So how do I know, what do I do with the vertical line test? What does that mean each of these graphs should have through them? A what? A line which direction? What does vertical mean?
Up and down.
Up and down, okay. So if I draw a line through this graph up and down, okay, and I draw one through this graph up and down, which one's a function? The left one, because the vertical line only passes through that graph once. So this is a function. When a vertical line passes through my graph more than once, it is not a function, okay? So that is one way. If you have something graphed already, that's the easiest way to tell if something's a function. Vertical line test saves you time. Okay? Function, not a function. How do I graph -2x minus 1? How do I graph that? Okay, so Isabel tells me -1 is my, where my y-axis is, where my, oh, I can't think right now. Yeah, what is that called when it's on there? the point,
Intercept.
the intercept, thank you, my y-intercept. So this is my y-intercept. What is this right here? It's, no, not my
Oh,
x-intercept.
slope.
It's my slope. And slope is rise over run. Okay. So if I go to -1 and I graph that point, -1 on the y-intercept, what does -2 tell me? -2x, what does that slope tell me?
Just going through the x, the
You can just talk. Not 2 to the left and 1 up. Go 2 down and 1 over, yes? Or you did it backwards, yes, I get what you're saying. Either way works. So I'm going down 2 over 1, or he said I can go, I could go up 2 and over 1 this way, okay? And so then I have this line. You're gonna pretend that my lines are perfect when I'm on the board this year, okay? So I have this line that looks like that, and I've graphed it, okay? A linear function, y equals mx plus b. This is the standard form for a line, for a linear function. You are going to see it written in function notation a lot this year, okay? Function notation means I can put any letter out here. I can say f of x equals mx plus b. I can say g of x equals this, anything, okay? This simply means this takes place of the y, so think of it it's kind of like the y in this case, okay? But what it means is whatever number I plug into x, okay, I get an output. I'm going to end up getting an answer. So if I have it in function notation, it's simply telling me that it's working around x. X is what determines everything, okay? That's function notation. Eventually, this linear function, the standard form, is going to go completely away, and you're just going to see everything in function notation. Okay, so get used to that. Don't freak out about it. It's not a big deal. It just replaces y. On this section here, I want to know if these equations are linear, and I want you to solve when x equals -4. So, let's decide if they're linear. Who can tell me if the first one, f of x equals -x squared minus 2x plus 7, is that linear? What? It does, correct. The formula is what type of formula, Isabel? It is quadratic. So is quadratic a linear function? No, it's a parabola, right? Okay? So it's not going to form a line. So no, not a linear function. Okay? So anything that has a power greater than 1 is not going to be linear. Pretty simple? Okay? Now let's solve. So Tyler is correct. He said if I have a negative on the outside and I'm plugging in a negative, is that going to make it positive? Technically, yes, but we have to take the square into consideration also, Tyler. So from here, order of operations, what do I do first? Parentheses or exponents. What is -4 squared? 6. Oh, yes, it's positive 16, but I still have this negative on the outside, right? -2 times -4? Positive 8, and then plus 7. Here I have technically -16, right? Plus 8 plus 7. What is -16 plus 8 plus 7?
-1.
-1. There's my solution. Now, is b a linear function? Is g of x equals 5x plus 8 a linear function? Yeah, it's a linear function. It's still in mx plus b form, right? So this is linear. Now, let's solve this linear function. Plug in -4. What is 5 times -4? -20 plus 8? Not -16.
Oh, he said 8. Okay.
-12. Good. Okay. So, this is what 2.1 is over. Good warm up for the first chapter. Yes, Brady.
How do you know if it's linear or not?
Linear only has a power of 1 in it. So if a power is higher than 1 at any time, it's not linear. So a quadratic function, a cubic function, they're not linear because I can't graph a line off of it. It has to be in mx plus b form. Does that make sense? Okay, that's that. I will give you homework.
I have a question.
What?
So, what, it's gonna be g of x equals -12 or 1?